All right, I guess we can go on and get started here. Good morning, everybody. Happy Monday to you. It's April 5th. We're already in the month of April, final month for us students. Oh, I guess for the faculty among us as well. Thanks for tuning in to this week's weather briefing. Pleased to welcome Penn State Meteorology Professor Dr. Kevin Bowley as this week's presenter. Gee, it's Monday and I'm already tongue-tied. Dr. Bowley, I will let you take it away before I have another slip of the tongue.
All right, sounds good, Chris. Thanks for the introduction, and good to virtually see everyone. Hopefully, everyone had a nice weekend and enjoyed the beautiful weather. I tried my best to avoid getting a sunburn for today's forecast discussion, but it was a little challenging yesterday with all the sunny weather and nice conditions out there. Before I was joking earlier. I was saying that I kind of drew the short end of the straw and the best straw all at the same time with regards to our forecast discussion this week, because it's a rather quiet day and kind of week ahead across the U.S. But at the same time, quiet weather and this time of year is kind of nice too, because it's usually pretty warm conditions as well. So we'll take a look at that a little bit later on. But I was perusing the maps this morning, and one thing caught my eye, and one thing that I sometimes will kind of use as a quick check-in to see how things are looking weather-wise across the country or around the world, is I'll take a quick look at where we're seeing record-breaking temperatures ongoing. And one thing that jumped out to me immediately was what's going on over in Europe. So what we're looking at here, this is a loop of the record high and low temperatures, or at least values within a few degrees of record high and record low temperatures across many areas. And as we're working our way from late March to early April, you'll see a lot of red showing up here across portions of Europe. That's record high or near record high temperatures. And then right at the very end here, you'll notice this massive burst of blue here. So we very quickly have gone from record high temperatures in the week, in the week preceding Easter and Passover, into a very, very harsh transition this weekend, or this Monday. And I thought I'd be kind of interested to look at from a few different perspectives. Unfortunately, with some of the challenges that are at hand right now with weather data that's been going on over the past little bit, finding some reliable anomaly maps has been a little bit challenging here. But there is one site at least that I've been playing around with, and I'll try and introduce a few new sites today as we're kind of working our way through the discussion. In this case, we're kind of looking at these are animations here of the past 5 or so days from the 500 hectopascal perspective and from a sea level pressure perspective here. All the contours here are the observed values, daily values here. So daily 500 hectopascal heights, daily sea level pressure contours or isobars here. And then the shading here is anomalous conditions. So whether or not we had anomalously high or low sea level pressure, or anomalously high or low heights at 500 millibars. And of course, as is often the case, if we're looking for a scenario for anomalously high temperatures here, oftentimes you're going to be looking for a ridge somewhere ongoing. So a little bit warmer conditions across the central U.S., and those spilled their way east over the past little bit. So certainly in the U.S., we'd expect to see some sort of ridging anomaly upstream or west of our location here. But if we turn our eyes towards Europe, you'll notice this nice bullnose here of ridging here working its way across. In this case, this is March 29th, March 30th. March 31st, reinforcing high coming in across portions of the North Atlantic here. So again, this is Europe here, kind of in this kind of top left quadrant here, working into April 1st. And then if you keep your eyes out here, there's this little shortwave trough kind of working its way into the Labrador Sea and up through off the shore of Labrador between there and Greenland right here. And as we jump forward one more day, you'll notice that jumps. So we have a scenario of lee cyclogenesis on the lee side or the downwind side of Greenland here. And that lee cyclogenesis jumps forward here, and I believe this is going to be the last step for this snapshot in time, but we can fill in the gap here by looking at what's going on in model land. This is our northern hemisphere kind of flow map scenario here. So just to give ourselves a scenario here with a slightly higher time resolution of what we just saw in the observations, but in this case, looking at the model analysis period, here's that ridge of the North Atlantic. There's that trough working its way up through the Canadian Arctic archipelago there, crossing over Greenland there. And then right at the tail end here, you'll notice that we have a shortwave ridge where that trough was. We have a very anomalous here. In this case, our shading here is standardized anomalies here, or height anomalies here. So these are 2 to 4 standard deviation low heights here over Scandinavia, high heights here over Greenland. And as we step our way forward in time here, we'll kind of take this snapshot at this point in time for this morning. So this is 0Z and 12Z this morning. So this is kind of our current point in time. And you'll notice here that we have a very, very sharp gradient here at 500 millibars. quite anomalously low heights to the east, quite anomalously high heights to the west. If you do your quick mental math here, that should give you a nice deep northwesterly wind. If we zoom our way in here on this region, we'll dive our way here towards the North Atlantic. We can see that anomaly a little bit more robustly here. We can now pop our way down to sea level pressure anomalies here. This is our sea level pressure response. You notice there we have closed contours in both instances, so closed highs and closed lows in that case. Let's give ourselves a chance for our sea level pressure to show up. There's been some data outages this morning causing some issues for some of our stuff. And here's our sea level pressure plot. So vertically stacked approximately systems, 1040 plus high here near Iceland. That's Iceland right there in the gray shading. And then in this case, a 960 something low over Scandinavia. So if you do the quick mental math on that, that's getting close to 100 millibar pressure gradient. In this case, across this 20 or 25 degree longitude distance here. That is a hauling pressure gradient. That's certainly outside of a tropical system. That's one of the stronger ones that I can recall seeing in quite a while in terms of the strength of pressure change there. Again, our isobars here are every four millibars here. So it's your eyes aren't deceiving you. This is quite the robust system. And in response to that, so in this case, again, about a 4 standard deviation, so a 4 standard deviation, or about four kind of steps in our standard deviation and away from being a normal low here. Likewise here, about 2 standard deviations away from normal for our high pressure there. Our wind speeds in response to this are really cranking. So really strong northerly flow in this particular case. And as you might imagine, it's rather cold up there at this time of year. If we take our temperatures at this time of year in that vicinity here, we're going to notice as it slowly but surely loads its way on in here. And we have this very robust surge of cold air being drawn out of the Arctic through very robust temperature advection. You can see our temperature, our isotherms here and our red contours here. And you can see if you do a quick solenoid analysis, a lot of cold air advection blasting its way into Europe. This is an area that doesn't oftentimes have excruciatingly cold temperatures, but especially cold air coming from this direction is not quite so normal. They're used to getting more cold air from the east in that particular case. And you can actually see this ongoing right now with our visible satellites. So in this case, if we kind of loop it here, you can see the classic scenario here with a nice robust cold front driving its way south here. And in this case as well, with this play through, you can see the telltale sign of cold air pouring over open ocean waters here with nice open cell convection here, nice cloud streets in response to that lower tropospheric convection. Warming from the surface, very cold air aloft, not deep convection because it's, of course, in this case, a rather capped inversion here, or a capped environment here with a strong inversion, but a really nice robust scenario at hand and some nice little cool mesovortices tied into that. So unfortunately for Europe, what that means is that this time of year, for those of you who are familiar with this time of year, places like Belgium and otherwise are chock full of tulips and all sorts of other things. Well, they're getting a quite robust freeze this time of year. So I'll be very curious to see what sort of impacts we might see, at least for the European economy, as they celebrate for many of them what is a state holiday for many of these nations with Easter Monday in this neck of the woods. So pretty cold day for a day off in Europe. In our neck of the woods, we of course here at the university have our final wellness day this Wednesday. For those of you who are student and faculty, I certainly encourage you to take as much time as you can to take some well-being time for yourself here at the university. And if you're not here at the university, I encourage you to find a way to create your own wellness day as well as you can in your current position as well as you can. Keeping an eye out in terms of what that means for us, I think it's kind of nice to give ourselves a sense. I feel like at least this spring, I've kind of lost track almost as to what normal is for this time of year for temperatures, because we've had such a kind of roller coaster of stretches of anomalously high and anomalously low temperatures. So one of the stops I went to first and foremost was Jared Rennie from, he's down in North Carolina. He has these great ArcGIS maps of precipitation, temperatures, all sorts of stuff. This is his kind of home landing page here with all sorts of stuff, meteorologically speaking, that are really quite helpful here. So things like the climate stripes that many of you have probably seen before, current year-to-date temperature precipitation departures, and so on and so forth. And I thought I'd start off by first taking us through a look at what first and foremost how we're doing from a precipitation standpoint. So this is our precipitation climatology. For those of you local, this is our 2018 maxima from a few years back. The kind of orangish line here is our climatological mean, and you'll notice that bit of a data outage at the start of the year, but we've been more or less running give or take below average for much of the year precipitation wise, but kind of keeping pace, at least with regards to our climatological maxima, or kind of a climatological background state. from a precipitation standpoint, but certainly at least in March, we had some pretty robust stretches of dry conditions. In this case, you can see March 1st to about March 10th was pretty dry. A couple of rainy days, another dry stretch, and we're lining up for another one of those potentially dry stretches here as we kind of work our way into the April timeframe on that front. Similarly within that, speaking of temperatures, these are our climatological temperatures. So in this case, our kind of max and mins are given here by the kind of lighter tannish kind of shading. The more grayish tan is kind of our average max and min range for this time of year. So you can see just a handful of days ago, we did have a record high low temperature during one of our overnight hours when we had a record high low temperature exceeding 50 degrees. Big cold surge that came in over the past handful of days, and the data, at least for yesterday, is not in yet. This is kind of cutting off prior to the weekend, but certainly poking our way back up into the warmer than average range. But certainly for much of the spring here, we've been running quite a bit above average, anywhere between 5 and 10 degrees above average on a routine basis here in the State College area. And that's going to continue right now about this time of year. Average high temperatures for early April are the mid 50s. Average lows are in the mid 30s. We've had some cooler mornings, but certainly our days, the next handful of days are looking quite nice. We'll kind of dive our way into what exactly is going on there. Taking a quick tour de force. So at least from the northern hemisphere standpoint, if we kind of look at what's going on here, we can see a lot of details going on. We have this nice robust cyclone here driving its way up the east coast. Actually, a lot of the warm air advection and moisture being driven poleward was what helped build that ridge east to the west of Greenland, which kind of helped set the stage for that huge pressure gradient in the Europe sector. But this is just kind of slowly but surely retrograding its way back into the main coastline here. And at least for us, we've been a little bit kind of protected by that with a bit of our ridging to the west, but certainly it's made for a pretty glum day across the eastern United States, or at least in the northeast US. And it is that time of year. It's back to our cold front season. It's cut off low season. And as we'll see, we're going to have all sorts of features like that ongoing with our forecast this week. Bit of a wave working its way across the central United States, kind of cresting over this ridge here. And then all eyes are kind of out west with this trough digging on the west coast. And we'll talk a bit about that in detail as we get deeper into the discussion. What do we have to work with, at least in terms of surface features and fronts? Well, at least across the country right now, you can see the first order here's that really nice occluded cyclone here off the east coast. This would be a fun map analysis here for Bill Syret's map analysis class. A lot of good stuff going on over there to kind of delve your way into. A little bit of a trough hanging out offshore here. In this case, if you kind of hone in terms of what's going on with the near surface conditions, at least for the time being with this circulation here, we're actually getting offshore flow, which is beneficial to the folks in New England this time of year. It actually might allow them to get a little bit warmer than average if they can tap into a little bit of that warmer air over our landmass there. This time of year, the oceans are quite cold, so any sort of easterly component of the flow is just bad news bears in terms of having nice conditions for them. Across the rest of the country, we have this really nice extended baroclinic zone, basically dragging east to west from the Virginias all the way across the California coastline here. Normally, if I would see this, I'd be a little bit concerned about the potential for a couple of storms to ride their way along that. And certainly that is the case. We do see a little bit of energy riding its way along these stationary boundaries. And of course, at the stationary boundary, the slightest bit of cyclonic circulation is going to kick off some warm air advection, the potential there for some precipitation and whatnot. But in this case, we don't have a lot of strong upper level force to really capitalize on this existing baroclinic zone. So it's just going to kind of hang tight for a while, and we'll kind of see how things play out on that front. So pretty quiet across the US right now, as you might imagine. And as we go ahead and kind of take our way looking through the weather for the next couple of days, we'll first start off by looking at what the pros are saying, and then we'll do a bit of analysis on our own. WPC right now for the kind of 24-hour snapshots that we're looking at. This is 24 hours starting this morning at 8 a.m. Projecting, a bit of precipitation forcing along that baroclinic zone, draping across the eastern U.S. Perhaps a few showers here in the State College area, and really pretty much where you see that area of baroclinicity is where we're seeing the majority of our systems attempting to form. By day 2, we start to see our system out west start to gain a little bit more steam here, and then by day 3, we really start to see it kind of become the dominant feature at hand across the central United States. But as you can kind of see within this, it's slow moving, right? It's starting off here in Idaho on day 1, day 2, it's over Wyoming, day 3, it's over Nebraska. That's a slow moving system, and that's indicative of the cutoff nature of the system that we're keeping our eyes on overall within that. So certainly some interest on that front. tied into that, you might have noticed a little bit of thunder potential and convective potential within that. And certainly within this on day one here, we're seeing a slight risk of severe weather across the Minnesota region. By day 2, we're looking at a chance of severe weather as that system starts to get itself organized here across portions of southeastern Kansas and northeastern Oklahoma. And by day 3, not much of a shift, just a little bit to the east. But in this case, with that large cold frontal type feature lingering across the central United States, the potential for severe weather through there. And we're just kind of getting our noses into it here in the State College area by day 3 there with that, that marginal risk actually for a couple of our days there overall than that. So let's get a sense as to just what exactly is going on. Why are we seeing such a robust response here in terms of slow moving systems, et cetera, et cetera? Well, start off, this is something near and dear to my heart from a forecasting and from a research perspective. I do a lot of work up in the dynamic tropopause. So the tropopause, of course, is just the capping layer between the troposphere and the stratosphere. I do a lot of work in what's called the dynamic tropopause, which is basically a thermodynamically derived version of it. So oftentimes we think about the idea of the tropopause being this inversion in the atmosphere, and we can define that using equations. In this case, we can define it using potential vorticity, and in this case, the two potential vorticity unit surface tends to be a good approximation of where we typically see the tropopause in the extratropical latitudes in the northern and southern hemisphere. From there, we can look at potential temperature and use that as a metric as to how high or how low we are in the atmosphere. You can also use pressure as a metric for how high or how low we are in the atmosphere here. So in this case, our kind of blue-purple colors here, if we're looking at it from a pressure standpoint, represent lower pressures. This tells us that our tropopause is closer to 4 to 500 millibars. And our warmer colors here tell us that it's closer to, in this case, say 50 to 150 millibars. So in this case, more of a tropical-esque air mass. In this case, more of a polar-esque air mass. I'm going to go back to theta because it's a little bit more well-behaved in this general case. And if we kind of take a look here in terms of what's going on with regards to our system, in this case, you can kind of analyze this in a not too dissimilar manner to what we typically see with our upper level flow. We'll link this to our 200 millibar heights in a little bit here. But we can see this nice kind of trough here of in this case, colder potential temperature values here working its way across the western United States. And as time works its way along here, we'll notice that this trough starts to dig its way to the east, get a nice enhancement here with a very strong temperature gradient, which can be thought of as a pressure gradient here. So a strong pressure gradient force, strong winds here, nice cyclonic shear on the northern side, anticyclonic shear on the southern side. You'll notice that these two features take on a bit of a cyclonic and anticyclonic sense of rotation about them. And as that system works its way further and further east here, we notice that by the time we hit midweek or so, and apologies for this being a little bit funky here, the website's always a little bit cranky on that front. But by the time we hit Wednesday to Thursday, you'll notice that this system doesn't really have too strong of connections here to what we saw before in the flow, right? At this point in time, kind of at in the early period, we can see this nice streamer here, still connecting it to the broader pool of cold air in the poles. By the time we hit the midweek period, it's kind of starting to lose some of that connectivity. And then late in the week, it's really a very kind of loose connection there to the larger scale flow and the larger scale jet stream overall than that. That's the classic sign of a cutoff low. In this case, we can see this nice cyclonic circulation, certainly here with the circular circulation suggesting a closed circulation in our upper level flow. And once something cuts off, you really have to have, more often than not, unless it just kind of spins itself out, you need something else to kind of swing in and kick it out. And in this case, our kicker is going to be this trough coming in from the west, which kind of helps to scoop that up and eventually attempt to pull it to the east. But throughout this, you'll notice that our troughs are not very fast moving, right? This first one kind of cuts into the central US, lingers for a while, kind of gets saved by the secondary trough coming in, but that one kind of cuts off too and sits over the Great Lakes for a while. And then eventually here we start to see a shift in pattern, perhaps towards the tail end of the period. But realistically, very, very slow moving conditions, deep northerly flow here across portions of eastern Canada there, potentially the chance for backdoor cold fronts. Lots of stuff to keep our eyes on from that perspective. To bring it down to a surface that you're maybe more familiar with, we can now look at our 300 hectopascal heights and winds here to get a sense of some of our forcing for ascent in the atmosphere here. So we can see that cutoff low starts to get a closed circulation here in our upper level pattern here by early tomorrow. Rides its way along that jet streak where we saw that enhanced gradient in temperature on our 2PVU surface, works its way to the east. But you'll notice here that this is very much disconnects from the northerly flow here. We can see our northerly kind of polar jet stream here off to the north, and then eventually dives to the south. We do see some enhancement and some help here from our subtropical jet stream, but that's not doing too much there on that front. Realistically, a lot of that's actually kind of disjointed here with this entrance region to the south here. But realistically within this, it's just kind of a big old closed off circulation that's not really doing much to help itself here in terms of strong forcing for motion or for strengthening with regards to our jet streaks overall from that. And it's not until that second trough kicks its way in and tries to kick to the east that anything happens. But across the board here, it's rather weak jet forcing throughout the entire event. And that's really symbiotic of our kind of cutoff circulations overall within this. As we work our way down to the vorticity perspective, again, nice strong shear base vorticity in this case initially, and then a lot of just just a lot of circular flow aloft, giving ourselves a nice strong vorticity response to the system. However, not a lot of vorticity advection, right? Closed circulation, it's hard to advect vorticity around a closed circulation. We see our secondary system kicking its way in here with strong PVA to the east of that, helping to drive it eastward in this case for our forcing term for motion from a QG perspective. And then as that starts to work its way in, those two eventually merge their way together and also start to cut off with time. So overall within this, just a lot of cutoff of flow, at least here in the State College, or if we kind of take a snapshot back in time here, you'll notice a little bit of vorticity forcing in this kind of broad area here on the downstream side of this ridge and kind of throughout this area. That's a lot of that forcing that we saw prior with our viewpoint with regards to our GO satellite, right? We saw a lot of kind of areas of cloudiness here. That's largely in response to that vorticity advection and that weak warm air advection at hand on that front. Speaking of warm air advection, we can also step our way forward within time within this. Again, large scale baroclinic zone hanging out across much of the United States. We can kind of imagine drawing out our baroclinic boundary here. And we can see that broadly outside of maybe this neck of the woods in response to this trough up to the north, we're not really seeing a lot of strong temperature advections here. A lot of our winds are parallel to that temperature gradient. So a lot of stationary systems at hand on that front. As we work our way forward within time, as our system finally starts to intensify, though rather at this point in time, it is kind of at its peak intensity here from a cutoff standpoint, we do see warm air advection to the south here. Nice delineation there with our warm front there. Bit of a cold front here to the south, certainly a bit of ageostrophic flow driving its way down the front side of the mountains here with a bit of a barrier jet, helping to draw some of that cold air to the south. But here into the east, just not a lot of warm air advection going on, nor cold air advection. We're just kind of slowly but surely nudging our way basically into the side of this ridge over the next handful of days here. And as time works its way along, we eventually get a nice call type pattern here with a trough here, ridge here, kind of sitting in the middle of those two. Kind of broad southerly flow there as time works its way along. And it's really not towards the tail end of the event that we start to get into this scenario here of more broad warm air advection as that second trough kicks through the east and starts to work its way into our vicinity. Now, tying all that together, the big question at hand, of course, is we've been pretty warm. Do we have CAPE? And the answer is not a lot, right? So we can see some enhancements of CAPE over the next couple of days in those areas of strong forcing, or those areas kind of highlighted by SPC with time. But for our neck of the woods, we don't have a lot of warm air advection working its way in, which also, generally speaking, for us this time of year and most times of year, also means we don't have a lot of moisture advection at hand. So though we might be getting into a slightly high CAPE environments, potentially with time, and by high CAPE, I'm talking like 40 to 100 joules per kilogram of CAPE. It's just going to be hard, honestly, for us in a lot of ways to get a lot of moisture into the environment. And a lot of that's being driven by the fact that we don't have a good moisture source right now near the surface. That's going to make CAPE rather hard to come by. We actually have pretty dry conditions and potential for fire weather today. So unfortunately, if you're looking for the potential for thunderstorms, I'm not going to be bringing the best of news on that front. But what we might see is just some broad convective showers as we see these kind of little kind of blips of vorticity working their way through here. So the slight potential for precipitation a little bit later on this afternoon and evening, if we kind of grab a snapshot in time here, we'll see that a lot of this is being driven not by surface-based convection per se, but instead actually by a broad moistening of our upper level environments. I'm very, very much in the mindset that I don't think it's actually going to make its way down to the surface. It is rarely very, very dry at the surface, and that is not enough precipitation in my books to really make its way down robustly to survive both crossing the mountains as well as dealing with the large scale deep dry layer here from 700 millibars downward. So we'll see. The atmosphere always has a way of humbling us, but my perspective is it's going to be very hard for these showers to make it down to ground level. We might feel a bunch of cooling, but not necessarily a bunch of showers. Working our way into Tuesday into Wednesday. So this is Tuesday during the afternoon. Again, kind of a similar scenario at hand here. Where we do have another system working its way across. A little bit more dry near the surface. This one's a little bit more productive and potential at hand there for precipitation, but it's not looking overly great from a forcing standpoint, so rather scattered from that standpoint. And then finally, towards the latter half of the week, Thursday into Friday, these systems finally start to kick their way east, we start to get to that better period of warm air advection. It certainly is looking a little bit wetter from that perspective. There's a few ways to look at this. I really like pushing my students. Many of you who have had me in 416 or other classes know that I like to push us a lot into Ensemble land. The WPC has a page that is rather overwhelming at times, but it is also a very, very helpful tool. This is their Super Ensemble viewer for precipitation, as well as snow and ice on this front. In this case, you can look at all 25 ECMWF members, as well as GFS members, STREF members, CMC members, and high-res members, as well as the outlooks, in this case, from the WPC for perspective, for precipitation. We'll just take a quick kind of look here through the day 1 to 3 totals. In this case, this is kind of combining everything prior to that cyclone working its way across here. And you'll see a fair amount of agreement in the west, but a lot of disagreement over portions of Pennsylvania. Some are going rather intensively after the precipitation. Some are going rather meekly after the precipitation on that front. So we'll see what the total impact of that is in the end. But certainly from this perspective, looking like the chance for showers, but not looking overly, at least kind of overwhelming from a forecast perspective as we work our way in within this. And this is at least this is what the pros have from the WPC perspective. In this case, our totals here, we're looking at the right around 100th of an inch, maybe a quarter of an inch at best on that front. Last but not least here, other way to view our ensemble data is the National Blend of Models 1D viewer, which is kind of like taking everything that we just looked at and packing it into a nice simplified viewer standpoint here. And if you recall, our average highs here are around 55 or so right now. And if we go towards the latter half of this period of time here, let's grab our trusty temperature map here. So at this point in time, as we're kind of sitting here in early April, we should see average highs around 55. By mid-April, we should be pushing up to around 60. And if we go back to our national blended models, you'll notice here that our temperatures here, this is that 60 line, that's 55. Temperatures are looking at or above average for an extended period of time. And this has been sitting in the long range models for quite a period of time. We have been seeing the progs for quite warm conditions for quite a period of time here, largely in response to that kind of static stationary flow across time. The models have been getting much less aggressive overall, the total precipitation from these events. Earlier this week, we were progging an inch and a half of precip for the Thursday event, at least with this latest round in the national blend, 0.3 of an inch. Towards the latter half here, kind of nickel and diming here, a whole bunch of potential for light kind of convective precipitation. Weak odds for thunder overall than this, but certainly the chance for kind of convective showers and kind of a few vorticity driven events here. But honestly, it's looking a little bit unsettled, but in the broad scale of unsettled, it's a pretty good outlook for us overall than that. Last but not least, we can take a quick look to see what our odds are at hitting the mid 60s here in State College. This is for tomorrow. Taking a look through all of our different models here at 18Z tomorrow, and you can see pretty darn good agreement across the board if they decide to load here. Give them one last shot here. You can see some of that agreement that we're seeing with the national blended models here as well by taking a multi-model ensemble kind of view overall within this. In this case, many of our models here are pushing out temperatures in the low to mid 60s by 18Z tomorrow. And if we were to look at other days, it's looking pretty similar on that front. So all in all, showery, pretty warm, certainly not the nasty weather that we're seeing over in Europe right now. And if we kind of look forward to what's going on within time overall within this is the 6 to 10 day outlook from CPC. This is the 8 to 14 day outlook, and this is the 1 month outlook overall from CPC. This is looking forward. The outlook made on March 31st, looking for April of 2021. So this outlook of warm in the east and warm across much of the US has been a dominant signal for quite a period of time. It seems to be holding true. So far, so good in terms of our robust 4-day verification here for April thus far. But it's looking like a pretty warm pattern overall, and a pretty nice pattern across most of the area. And a little bit of April showers are not too bad. I would say, I wasn't saying April showers bring May flowers. Unfortunately, we've had such a warm spring that our May flowers came up in March. But certainly looking to kind of continue on that trend of warm, maybe a bit showery, and all in all quite pleasant overall than that. So I will wrap up there. If anyone has any questions, I'm happy to answer them or chat about them. If anyone wants any links, just fire away in the chat, and I'll send along some links as well. And thanks for having me.
You're most certainly welcome, Dr. Bowley. Thank you again for presenting. I see that several of us have already been taking advantage of the chat, but if you have any questions for Dr. Bowley or anything else you'd like to say, please take advantage of the chat. We also have the Q&A available for discussion as well. I'm not really going to be much of one to complain if we have some of those convective showers over the next couple of days. It's been feeling a little bit dry out there.
Yeah, today I was actually surprised. Actually, admittedly, I have to say I didn't take a look at the outlook here in State College. I'll be curious how close we get to the potential for red flag warnings or similar on that front.
I remember, I guess it was yesterday, NWS State College put a thing out on Instagram basically saying, "Oh, there's already an elevated risk," but they didn't pull the trigger on the red flag warnings.
Yeah, it's going to be intriguing. I mean, when you look at our outlook for today, I mean, we have a wet bulb temperature of 31 Fahrenheit. Temperatures. I think the big kicker today and the big question at hand is really how much we can get those wind speeds up. Right now we're progging for the potential for 15 mile per hour winds gusting up into the low 20s. That combined with the wet bulb is actually awfully close to the threshold that we oftentimes draw for lines in the sand with regards to fire danger risk. Tomorrow's looking a little bit better on that front, and certainly our dew points kicking up here to much warmer temperatures overall than this. Just as a reminder here for everyone that sorry, I should have said earlier, the dew points are going to be 31 today. Dew points are the solid lines here. Wet bulbs are the dashed line here. So still dry tomorrow, not anywhere near as dry as today. But certainly if we get some windiness picking up, I would not be surprised at all in our neck of the woods. It's like the Weather Service is not responding to me right now, which is always a little bit dicey. They've had some issues over the past little bit here.
Oh, really?
You can pull up the weather and hazards page here, though, instead. Yeah, nothing up for Central PA yet, but yeah, certainly I think I'd see the same thing, Chris, if they had mentioned the chance for an elevated risk of fire today, but not quite at red flag warnings so far overall from that.
All right. Well, I am not seeing any more chatter in the chat. So I think we can all part ways here. And thank you again, Dr. Bowley.
All right. Thanks for having me, Chris. Take care.
Yeah, thank you. This weather briefing and all other weather briefings will be archived on Campus Weather Service's YouTube page at youtube.com/Campus Weather Service. And next week we will have, oh goodness, I forgot. Dave Dombeck from AccuWeather will be giving next week's presentation. Almost forgot. That'll be at the same time in the same place at 10:15 Eastern. I look forward to seeing you all next week. Have a great week, everybody.